So 3, 6, 9, multiples of 3 on the review. Again, the review is optional, not required, but pretty close to the test in some areas, so helpful to look at, probably to do some of them. Jump into number 3. Number 3 is poorly worded because the absolute value of this thing would not be r cis theta, it would just be r, so that should be gone. Because absolute value means distance, it doesn't mean the cis theta part. So if we just mark that out, we can find r. I think this one may have been wrong on the key.
Yeah.
So r squared equals 4 root 2 squared plus 3 root 4 squared. Again, we don't include the I. The I is there just to tell us that that's the imaginary piece. That's the up and down axis. So 16 times 2 plus 9 times 4. That would be 32 plus 36 is 68. 68 does have a perfect square in there. So 2 square root of 17. In calculus, you get to leave square root of 68. In pre-cal, you need to still be reducing or simplifying radicals. Soon enough. Number 6. The graph indicates 4 points in the complex plane. Each complex number has polar coordinates r and theta. Which of the following completes the expression for the 4 points in the form 5 cis theta? So what angle is it? Well, we start at 0. They're pi over 4 apart. Or no, pi over 2 apart, excuse me. So none of them start at 0. That's okay if we start at pi over 2, I guess. They're pi over 2 apart, so it's got to be B or C. There's not one at pi over 4. There is one at pi over 2, so it's got to be C. I would have preferred that start at k equals 0, because they're saying this is the first one and the second one, but no, they're saying this is the first one. But that's okay, it gets them all, because you loop around. Number 9. Oh, we haven't done one like this in a while. It's not hard, but we haven't done it. Z1 times Z2. I'm going to rewrite this just because it's easier to see it when we write it as a cis number. So Z1 times Z2. What do I do with the numbers? What do I do with the R's? Multiply them. So 40. And what do I do with the angles? Add them. So out to the side, 4 pi over 15 plus 6 pi over 15. Get a common denominator. Is 10 pi over 15. Which is 2 pi over 3. And why is that not my answer?
Because it's really standard.
Because it says standard form. There's only 2 of them on the test that matters, because there's few free response. And when it matters, I think I bolded or italicized standard to be like, hey, don't forget to, if you get this as an answer, it's not wrong, it's just not done yet. Let's see, cosine of 2 pi over 3 would be negative 1/2. Sine of 2 pi over 3 would be root 3 over 2. Again, this is a spot where you can show 100 steps, or you can show no steps, or you can show some amount in between. Negative 20 plus 20 root 3i. So again, just read the directions carefully. Trig form versus standard form. that's an easy one, but we haven't done that in a while. Just the straightforward multiply the coefficients and add the angles. Number 12. Well, same kind of thing, except we got powers going on. Let's see. So that would be 2 squared cis 10 pi over 6. Oh, that reduces. So well, I'll get that in a minute. Over 4 squared, 16 cis 8 pi over 3. So 4 cis 5 pi over 3 over 16 cis 8 pi over 3. Okay, so now I took care of the top, took care of the bottom. Now I can combine. 4/16 is 1/4. 5/3 minus 8/3 is negative 3/3, which is just negative pi. And now I'm on to their wicked ways here. Standard form, not trig form. So 1/4. I'm going to write this one out. Cosine of negative pi, same thing as cosine of pi, is negative 1. Sine of negative pi would be 0. So all of that to get an answer of negative 1/4. Number 15. Number 15. That to the 10th. Okay, I definitely do not want to do that to the 10th right now. I want to change that into trig, and then I can use the tricks, and then I guess I'll have to change it back to standard. So there's my roadmap there. Change it to trig, then mess with it because it's easier to mess with it in trig form, and then obviously I got to change it back. This is going to be a 30, 60, 90 over 2 down 2 root 3. So 30, 60, 90 experts, can you spare me the trouble of doing a squared plus b squared equals c squared? It's 4. Which is 2 squared, which looking ahead might be a better way to phrase that. So 4 cis, let's see, you said it was 30, 60, 90, so it's the steep angle in the 4th quadrant. That would be 5 pi over 3. All to the 10th. Yeah, I'm looking ahead. I don't want to do 4 to the 10th when my answers are all 2 to some power. So I'm going to sort of rewrite 4 as 2 squared. So then I get 2 to the 20th cis 50 pi over 3. Okay, I don't know where 50 pi over 3 is. I need to subtract 2 pi a whole bunch of times. So I need to subtract 6 over 3 a whole bunch of times. So some of you can kind of think ahead and figure it out. Other people are just going to be like, meh, 44, 38, 32. Better not do this too fast. 26, 20, 14. Here we go, getting there. 8 and 2. That's me subtracting 2 pi all the way down.
In like one of the videos, or not videos, like answer keys, Miss Murray would do like the highest multiple of 6 so that she didn't have to keep
correct. So, yeah. So is it worth to think about what's the highest multiple of 6 that's less than 50? Or is it easier to just subtract all the way down? Either way. The highest multiple of 6 less than 50 would be 48. And if we subtracted 48, we would end at 2. So however we get there, we should land at 2 pi over 3. because that's 2 pi, and I want all of these are coterminal. But the only one I want is the one that's easiest to deal with, 2 pi over 3. So I could use any of those. Those are all the same spot on the circle. I just want to use the easiest one. So 2 to the 20th. I think A and B are sucker bets right there. Those are not really the right answer. Cosine 2 pi over 3 is negative 1/2. Sine is root 3 over 2. And so you look at what they did. They took one of those 2's from the 22's that are out front. They took one of them to cancel the inside. So I'm going to show more work than is really needed here, but I'm going to take one of those 2's so that I can use it on the inside stuff and not have fractions anymore. So that's where the 19 comes from. So 2 to the 19th, and then that 2 cancels and cancels. So we thought it was 2 to the 20th, but not really, because we used one of those 2's to cancel things on the inside. So 2 to the 19th, negative 1 plus root 3i. Yeah, there was a lot going on in that. We had to change it to trig. Then we had to do the trig stuff, and including a coterminal business. And then we had to change it back to standard, where we had to be careful with that 2 to the 20th out there. Number 18. Determine the 3 cube roots of 8. Write your answer in standard form. Stop it with the standard form already. Hey, I know one of the answers, right? Before I even get started. If x cubed equals 8, negative 8, then negative 2 should be one of my answers. But let's do this sort of the more formal way and hope, that we land at negative 2 for one of my answers. Let's see, so negative 8's over there. So that's 8 cis pi. So we'll cube root both sides. So x equals 2 cis pi over 3. That's my first answer, the principal root. My other 2 answers will add 2 pi over 3 to get my other answers. So pi over 3 plus 2 pi over 3 would be pi. And pi plus 2 pi over 3 would be 5 pi over 3. And if only they had answered or asked for trig form, we'd be done. Instead, let's see, pi over 3, cosine of that's a half, sine of that's root 3 over 2. So that would be 1 plus root 3i. That's one of my answers. 2 cis pi. Okay, so cosine of pi is negative 1. Sine of pi is 0. So there's negative 2. So I did get negative 2. I was pretty sure we would get there. And there it is. And then lastly, 5 pi over 3. Cosine's a half, sine's negative root 3 over 2, so 1 minus root 3i. So there's my 3 roots of negative 8. So if I cubed any of those 3 numbers, I should get negative 8. Here's where I could check on the calculator, even using i's. So 1 minus square root of 3i cubed is supposed to be negative 8. And it is, if I'll put it back in the right format, negative 8. Number 21. Oh, finally, reduced to trig form. find all the solutions, real and complex, of x to the 5th equals negative 32. How many solutions should I have? 5. I do get to leave it in trig form, so that's nice. Negative 32 is over there. Here's another one where I should just get negative 2 for an answer. Oops, not negative 32. 32 cis pi. And then raise that to the 1/5. So that's 2 cis pi over 5. And to get my other answers, I'll add 2 pi over 5, because I got to have 5 answers equally spaced around the 2 pi circle. So 2 cis 3 pi over 5, 2 cis 5 pi over 5, also known as pi, 2 cis 7 pi over 5, and 9 pi over 5. There's my 5 answers. I know I need to stop there. If I want to do that check where I add one more and make sure I wrap around to where I started, the next one would be 11 pi over 5, which is coterminal with pi over 5. So that's a little bit of a check that I'm pretty sure I got those right. Okay, that was the multiples of 3.